Our lecture number 4 of deflection of truss. So content of today's lecture are: first is recap of lecture number 3, then lecture outcome of this current lecture, and numerical on support displacement. So in today's lecture we are going to see one typical problem of support displacement. Okay, so let us begin with the recap of our third lecture. So in last lecture we have seen this example. Okay, so there was a truss ABCD like shown in figure, and horizontal load of 81 kilonewton is acting on point C. Okay, so in last lecture we have found out support displacement of support B. Today's lecture, so outcome of today's lecture are, again, the first outcome will be apply unit load method for displacement of determinate truss and determine support displacement under given loading. Okay, so these are our lecture outcome of today's lecture, and directly we will go to the problem. This problem I have taken from Analysis of Structure Volume 2 by Vajirani Ratwani and Duggal, 16th edition book of 2011, and on page number 181, which is given. So in this problem, two important things are whatever mentioned here is tension members are stressed at 100 Newton per mm square, and compression members are stressed at 60 Newton per mm square at any point for truss. So we know that deflection is given by PKL divided by AE. This is formula for our deflection. Now what is formula for stress? Let us say stress I will indicate by sigma. So what is formula for stress? Just 1 by P by A. Okay. Now in this formula of deflection, if you observe, we are having these two terms, that is P by A. So whatever this is given, this is nothing but your stress. That P by A in the formula of deflection is nothing but your P by is stress. Okay, now in problem it is given that compression stress is 60 Newton per mm square and tensile stress is 100 Newton per mm square. So in this given truss, we have to first analyze this entire truss for this load of W. Okay, and first of all we have to find out which are the tensile member and which are the compressive member. And now after finding out this what natures of each and every forces due to this W load, then whatever whatever forces are tensile one, at that location we have to write down directly value of P by A is equal to 100 Newton per mm square, and whatever compressive forces are or compressive members are there, at that point we have to write down value of C is equal to 60 Newton per mm square. Okay, so somewhere here I will just show you what will be that final table for this particular case. So generally we are writing down first serial number column. Okay, then second column will be member. Okay, then third column will be, usually our third column is P. Now our third column will be here P by A. Okay, and here whatever forces, whatever members are compressive one, for that we will write down P by A is equal to 60, and whatever tensile forces are there, for that we will write down P by A is equal to uh, tensile forces 100. Okay, then next column will be K, the next column will be L, and directly final column will be PKL divided by AE. This will be our final column, and this T or compressive stress or tensile stress is nothing but directly P by A values for compressive and tensile members are given. Okay, so for that, first of all we have to analyze this entire truss to know the nature of forces only. Okay, now here if you see, this theta is going to be 45 degree. Why 45 degree? Because if you take tan of this theta, so tan of theta will be in this particular triangle DBC, if you take tan theta. Okay, so if you take tan theta, it is going to be 3 by 3. So tan inverse of 1 theta is going to be 45 degree, and sin theta will be 0.707, cos theta will be also same 0.707. Okay, and in problem it is asked that to find out horizontal displacement of roller bearing, that is support B. Okay, so for this support we have to find out horizontal displacement. Okay, before that we have to first analyze this truss. Okay, so just take, we will again draw this truss. Okay, so first of all, we will find out reaction forces. So I will take summation of moment about joint A. First of all, moment about joint A is equal to 0. So it will give us first this RB into 6. Okay, it will act in anti-clockwise direction. So minus RB into 6 equal to or plus this force W. So W into now total distance between this W force and support A will be 3 plus 3 plus 3, that is 9. So W into 9, that will be clockwise, which is equal to 0. Okay, so this force W will act in clockwise direction, RB will go in anti-clockwise direction. Okay, that's why RB is taken as a minus and W is taken as a plus. Okay, so if you solve this, you are getting RB is equal to 0.5 times W. Okay, so RB is equal to 1.5 times W. And now if you take summation of Fy is equal to 0, so we will get RA plus RB is equal to W. RA is going to be 0.5 times W, but it will be minus. Okay, why minus? Because RB is 1.5 times W, it will go to right hand side, it will become minus W minus 1.5 times W. So RA direction should be in downward direction. So RA should act in downward direction. So here we will show that RB as 1.5 times W and RA as 0.5 times W going downwards. Okay, now we will analyze this entire truss first of all. Okay, so so we will select joint A first of all, and remember these calculation we are doing only to find out nature of each and individual forces, because we know that if compressive nature is there, then stress in compression is 60 newton per mm square and stress in tension is 100 newton per mm square. Okay, so we are doing this only to find out nature of forces. So here I will first draw free body diagram of joint A. Okay, we will assume first of all direction. So let us assume AF is going away from joint, and similarly AG is also going away from joint because external force is acting in downward direction. So we will say that these internal forces will go away from the joint. Okay, so we will first of all take, you take summation of Fx is equal to 0, then no any horizontal force is acting, there will be only horizontal component of AG. Okay, so let me first draw here component of these forces. Okay, so this will be 0.707 times PAG. I am directly taking cos components. Cos component is 0.707 and sine component is also same. So both components will be having same value. Okay, so if we take summation Fx is equal to 0, then there will be only one equation, that is, or one quantity, 0.707 PAG is equal to 0. So directly PAG we can write down as a 0. Okay, now PAF will be directly, if you take summation Fx, Fy is equal to 0. If we take summation Fy is equal to 0, you can see PAG is directly 0. So PAF will be, or summation Fy is directly going to be PAF is equal to 0.5 times W. So we have found out this value of PAF, 0.5 times W. So we are only interested with the nature of forces. So let us draw here nature of that force. So it is going away from joint. So at this also it will go away from joint. PAG is 0 force member. Okay, nature we will assume going away from joint here also. Both forces will go away from joint, we will assume in that fashion. So two components of this force will be 0.707 times PFE, 0.707 times PFE. So if we take summation of Fy is equal to 0, you will get 0.707 times PFE is equal to 0.5 times W. So PFE is going to be 0.5 by 0.707 is equal to 0.707 times W, and if you take summation of horizontal forces equal to 0, then you will get this PFG. That so both forces are going towards right, so 0.707 times PFE plus PFG is equal to 0. So if you take to right hand side, PFE is 0.707 times W. So 0.707 into 0.707, it will be 0.5. Okay, PFG is I think negative 0.5, so we have to reverse the direction. Okay, it will give us PFG is equal to minus 0.5 times W. So minus means we have to reverse this direction of PFG. PFG should be reversed. At joint G, from bottom there is member AG is meeting, but member AG is a zero force member. If you see here, member AG is zero force member, so only we have to consider these three members only, member GF, member GB, and member EGE. Okay, and in that also member GF is known to us. Okay, we will assume PGB will go towards the joint, and let us assume PGF will go also towards the joint. What will Fy is equal to 0, you will get PGF is equal to directly 0. Here PGF is directly going to be 0 because external vertical force is not acting, and if you take summation of Fx is equal to 0, then you will get PGF is equal to PGB. So PGB is directly going to be 0.5 times W. Okay, so that will also we will show in diagram. PGE is zero force member. Okay, now if we take summation Fy is equal to 0, you will get PCB, and after summation Fx is equal to 0, you will get PCD. Okay, so now Fy is equal to 0, this value of load is W, so 0.707 times PCB is going to be W, so PCB we are getting as W by 0.707, 1.41. So now you will get PCD plus 0.707 times PCB is equal to 0. So now you will get PCD is equal to minus 1 minus 1 W. Okay, so if our answer is minus, that means we have to change direction of that. Okay, now we will consider joint D. If you consider joint D, then after taking summation Fy is equal to 0, you can say that directly MDB is equal to 0, and summation by taking summation Fx is equal to 0, you will get PDE is equal to PDC. Okay, so these two forces are also going to be same. Okay, so I will not resolve here joint D. Now we will directly go to joint E, summation of Fy is equal to 0. So P EB into 0.707 is equal to 0.707 times W into 0.707. So PEB is, I think, again same 0.707. EB is 0.707. Okay, now here please see this diagram, and now here what we will do, we will write down nature of forces. Okay, so we know the nature of each and every forces now. Now what we will do, in this table, first of all we will write down name of members. Okay, so there are 11 members are given. Now after this we will write down nature of these forces here only, just for our information in bracket. So these are members given in given truss and their natures. Okay, so now we will directly write down P by A values. So in problem you have seen that compressive stress is given as 60 Newton per mm square and tensile force stress is given as 100 Newton per mm square. So in this table, wherever T is there, that means wherever tensile forces are there, those we will denote by letter, or these T letters will indicate tensile nature of forces. Okay, and C letter will indicate compressive nature of forces. So this is only different part in this problem. That means instead of writing down value of P, we will directly write down value of P by A, and these value of P by A are directly given in our problem. Okay, so depending upon that we have written down this value. Now in problem it is asked to find out values of or displacement of support B. Okay, so apply horizontal unit load at joint B, that will give us displacement at support. So I have calculated those values, just confirm afterwards. So after applying horizontal load at joint B, you will get member force in member number. Okay, and now after solving this, or after finding out that member length L, I will not write here, I will directly write down PKL by AE. So for CD it is, now here I am only calculating PKL by A only. E I will write directly divide at the last moment. Okay, so BE is, I think, and if you take summation, then it will be minus summation of PKL, that summation is going to be minus 630, and lastly the 630 by E is given as 2 into 10 raised to 5. So summation of P delta is going to be summation of PKL by AE. So PKL by A we have found out as 630. So minus 630 divided by 2 into 10 raised to 5 Newton per mm. So this answer is going to be minus 3.15. Okay, so this answer is going to be 3.15. Here we have to multiply this by 100, because this 630 here length I have taken in meters, so that deflection at support B is calculated as minus 3.15. So so this minus sign indicates here we have applied unit displacement towards right, so we are expecting that the support B will displace towards right, but our answer is coming as a negative. So that means whatever our applied unit load is there, opposite to that direction this displacement will occur. Okay, so here we can just simply write down that deflection is minus 1.3 is towards left. Okay, we have applied load towards right, so this deflection will be towards left. Okay,